Hello, everyone. Welcome to the Math Magician's Den. We are going to discuss the difference between secant lines and tangent lines, the difference between average rate of change and instantaneous rate of change, and how this all relates to difference quotients. And eventually, we'll talk about derivatives in some other videos. Now, if you notice very closely, there is a function right here, this curve that's going through this graph. That's f of x. And you should also notice that there is a line passing through this point P on the curve and this point Q on the curve. Those 2 points and this line passing through them form what we call a secant line. A secant line for a circle is a line that passes through 2 points on the circle. So a secant line to a curve, it passes through 2 different points on the curve in a specific interval. Now, how do we find the slope of this secant line? Well, when you look at the slope of the secant line, it starts at P, which has an x value, and the y value for P is f of x. Now, we already know if I move a specific distance along the x-axis, we like to call that delta x. So this other coordinate would be x plus delta x, and its y value would be f of x plus delta x. So how do I find the slope of that line? Well, I take the change in these two y values, f of x plus delta x minus f of x, all over the change in these x values in the same order, x plus delta x minus x. Now the top is not going to simplify, but the bottom, that x minus x cancels, and of course, the change in x is going to be delta x. This is called a difference quotient, delta y over delta x. And where have you heard delta y over delta x before? Well, delta y over delta x is how we find slope. This is the slope of a secant line. A secant line, ladies and gentlemen, represents an average rate of change. Okay? Secant lines are average rates of change. Now, just to get us started, I'm going to take a look at a graph on Desmos here. We like to do this as well. A is an x value, a specific number. Sometimes in certain books, they like to use C instead of A. I'll kind of explain that later too. Now, if you notice here, from A to A plus H, delta X is H. And some books and some instructors like to do that as well. It kind of depends on the book, depends on the instructor. H is just delta X. So when I move from A to A plus H, my Y values should move from F of A to F of A plus H. Now, if I go back to my other screen and I write this difference formula, it's going to be F of A plus H minus F of A. Those are the Y values you saw on that graph. And then the X values were A plus H minus A. And of course, the A's cancel, and I get F of A plus H minus F of A all over H. There is no difference to that formula than the other one. It's just instead of X, A is a specific value of X. Down here, it likes to use C instead of X, or instead of A. Now, why do we have that graph on Desmos? Watch what happens if I let A stay put over here at x equals 2, and I start to make H smaller. I'm going to let H get smaller and smaller, and H is delta X, so H or delta X, they are both approaching 0. If I let H or delta X approach 0, tell me about my line. That line doesn't look like a secant line anymore. That line, to me, looks like a tangent line. So here's the thing. If I let delta x approach 0 of f of c plus delta x minus f of c over delta x, if I let delta x approach 0, it actually approaches the slope of a tangent line at a specific point. Okay? If I wrote this formula with the h's, it would be the limit as h approaches 0 of f of, and again, c is just a, it's just an x value, a plus h minus f of a all over h. This is how you find the slope of a tangent line at a particular point. And what is a tangent line? A tangent line is not an average rate of change. It's an instantaneous rate of change. What's the difference between an average rate of change and an instantaneous rate of change? An average rate of change would be something like this. Most people drive cars. Let's say you made a trip of 300 miles, and it took you 6 hours to make that trip. How fast were you going? Well, if you take 300 and you divide by 6, that's 50 miles per hour. But that's not your speed the whole time. That's your average speed. That's your average rate of change. Now, I bet during that trip, at some point, you could have looked at your speedometer, and at that instant, at that moment, you were going 50 miles per hour. That is the slope of a tangent line. That's an instantaneous rate of change. Now, I want to show you that these formulas actually work to find slopes. So what we're going to do is we're going to look at a couple of examples. The first one, we're actually going to find the slope of the tangent line at a point on a line. You're probably thinking to yourself, well, hey, this is easy. If this is a line, I already know that the slope is 4. So what I'm going to do, I'm actually going to use this formula to show you it comes out to be 4. We're going to do the limit, and I'm going to use h approaches 0 of f of a plus h minus f of a all over h. And again, I could have used c instead of a. I could have used delta x instead of h. But what we're talking about here, what's a? A is the point of tangency, so a is 2. So right here, you got to think of a as being 2, but what's f of 2? Well, f of 2 is the 11. So if I'm going to rewrite this, the limit as h approaches 0, f of a plus h, you're just plugging a plus h into x right there. So 4 times a, which is 2, plus h plus 3. And then f of a is going to be 11, so we're going to minus 11. And this is all over h. So in the dark blue, that's f of a plus h, a is 2. In the light blue, that's f of 2, f of a, that's 11. So we subtracted 11 all over h. Now how would this simplify? Well, we've got distribute, I get 8 plus 4h, and 3 minus 11 is negative 8 over 4. And you should notice you've got some stuff that cancels here. Those h's cancel. I end up getting the limit as h approaches 0 of 4h over h, but then the h's cancel. What's the limit of a constant? It's the constant. It's 4. Holy crap. It gave me the slope of the line. It does work. Now, I'm going to do something a little bit different here. We're going to do the same procedure, except I'm going to find the slope of a tangent line at any point. In other words, I want a formula for the slope of the tangent line. This time I'm going to use the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. And this time I'm not going to tell you what x is. I'm not going to give you a value. So how do I do this? You'll notice I'm not using h this time. I'm using delta x, and it doesn't matter which one you use. What is f of x plus delta x? Well, I've just got to plug that expression in for x. So it's x plus delta x squared plus 2. And what is f of x? Well, we have to subtract the original function, which is x squared plus 2. And this is all over delta x. Now, I've got some work to do here. So to make sure I give myself plenty of room here, and I'm going to try and stick to my same colors. The maroon color, the purple color here, if you expand, you would get x squared plus 2x delta x plus delta x squared, and then, of course, there's the plus 2. That orange color that rust color, if you distribute, you're going to get minus x squared minus 2. And then, of course, on the bottom, I still have delta x. Now, we're going to simplify all of this. The x squared minus x squared cancel. The 2 minus 2 cancel. And you'll notice I've only got 2 terms left here. My 2 terms I have left are this one. And if I divide that by delta x, I just get 2x. I've got this term. What's delta x squared divided by delta x? Well, it's delta x. Now remember, it's not x approaching 0 here. Delta x is approaching 0. So I get 2x plus 0. I get the expression 2x. If you wanted the slope of a tangent line at x equals 2, this graph, if x is 2, y is going to be 6. At that coordinate, the slope is what? It's 2 times 2. It's 4. If I picked a different point, let's say I'm going to pick a negative number. Let's say -1. If you plug in -1, you're going to get 3. Plug -1 in for the slope. You get 2 times -1. The slope there is -2. Now, what does this tell me? If you looked at the graph, at 2, 6, the graph has a positive slope. It's going uphill. If you looked at the point -1, 3, as you're moving left to right, the slope is negative. You're moving downhill. Welcome to derivatives. That 2x that we found right there, that's actually the derivative of x squared plus 2. If you like this video, please hit the like button. If my videos have been helping you out, please, I would ask you to subscribe to my channel. I'll be posting more videos as time goes by.